Hello guys, welcome back. So today we'll solve some questions on probability. Going to the first question. So out of 13 applicants for a job, there are 5 women and 8 men. So 13 people, we have 5 women and 8 men. 2 persons are to be selected for the job. Okay, 2 selected. The probability that at least one of the selected persons will be a woman is okay. So we want to find at least one, meaning 1 or 2, right? So what are the events we have? Let's say so both are men, both the selected people are men, or one is man and one is women, and C is both are women. So if you see, these 3 events are mutually exclusive. Right? So mutually exclusive meaning their intersection will be 0, right? Probability of the intersection. That is to also say that when one is occurred, the other cannot occur. So if both are men, then one cannot be women, right? So that way. And also if they are exhaustive. So what does exhaustive means? P of A union B union C is equal to 1. So all 3, the union of all 3 will exhaust all the possibilities. They will make sure that all the possibilities in the sample space are inside these 3, right? So since they are also mutually exclusive, their union I can write as, I can separate this like this. Correct? Okay, and what I need to find? At least one of the selected person is women. So I need to find P of B union C, which is nothing but P of B plus P of C. So this things I am possible to write from the union is because they are mutually exclusive, right? Okay, so there are 2 ways to find this answer. So I can either find P of B and C and add them, or I can find P of A and subtract from 1, right? So both ways will yield you the same answer. So since P of A I have to calculate only once, I'll go with that approach. So P, what is P of A? Both are men. So from 8 people I select 2. Both are men, right? And then total possibilities from 13 people I'm selecting 2. Right? So this I can expand 13 factorial by 11 factorial into 2 factorial. 2 factorial cancels, and this one I'll get as 8 into 7 by 13 into 12. So this is like 4th table, 2 and 3. So 14 by 39, and I want P of B plus C, which is nothing but 1 minus P of A. So it is 1 minus 14 by 39, which will be 25 by 39. So this is the answer. So at least the probability that at least one of the selected person will be a woman is 25 by 39. Moving on to the next question. A bag contains 4 white and 2 black balls, and another contains 3 white and 5 black balls. If one ball is drawn from each bag, find the probability that both are white. So I want to find the probability that both are white. But if you see, the drawing from the first bag is independent of drawing from the other bag, right? In no way the probability of white being drawn from the first bag is influenced by the probability that white being drawn from the other bag. So both are white, I can write it as first bag ball is white union second bag ball is white. Sorry, it is intersection, right? We want both to be occurring together. So they are independent. So I can just write it as first bag ball is white into P of second bag ball is white. So what is the probability that first bag ball is white? So it is 4 by 4 plus 2. 4 by 6 into second bag, it is 3 by 3 plus 5, it is 8. So this will be twice, this will be twice, so I will get it as 1 by 4. So here we have used the property of independent sets. So this way you can easily solve it. 1 by 4. Okay. Moving on to the next question. A batch of 50 transistors contain 3 defective ones. 2 transistors are selected at random from the batch and put into a radio set. What is the probability that both the transistors selected are defective? Okay. So there are 50 transistors. 3 are defective. So how many good ones are there? 47 good ones. And 2 transistors are selected at random. Okay, 2 are selected and put into a radio set. What is the probability that both the transistors selected are defective? So P of both defective. So you already know this is straightforward, right? So from 3 I select 2 for both to be defective, and total possibility is from 50 transistor I am selecting 2. So this is nothing but 3 factorial by 1 factorial into 2 factorial by 50 factorial by 48 factorial 2 factorial. So these cancels, and this I will get 3 into 2 divided by 50 into 49. So this is 25. So 3 by 25 into 49. So 25 into 49, how can I easily calculate this? I'll first calculate 25 into 50, then subtract with 25. So this 49 basically I write as 50 minus 1, and then I multiply inside. So this is 1250 minus 25. So which is 1225. So this is 3 by 1225. That is the answer. Again, if you see here, if instead of selecting at random, both selecting at the same time, if I say first I select 1, then I select 2. So do you understand the difference? Let's say this is experiment 1 and experiment 2 is so I leave hand inside the bag and take 2 transistors. Take 2 at the same time. So this difference comes, right? Can you guess whether this, like assuming either experiment 1 or experiment 2 will change the answer? So actually both will give the same answer. So what is happening is, in this case if you see, the order matters. Order in which the transistor comes out is mattering, but in this case order doesn't matter. So if order is mattering, what will we do? We'll take permutation, right? So if you want, for this example, let's say both are defective, I will say from 3, 2 I am taking. The order in which I am drawing will matter, correct? And if you see the total, this will be 50p2, correct? 2 I am drawing. So if you see, this is 3 factorial by 3 minus 2, 1 factorial by 50 factorial by 48 factorial. If you see, between this and this, the 2 factorial is common between numerator and denominator. So we are able to cancel it. So either if you take P or C, it doesn't matter, right? 1. Out of pack of 52 cards, 1 is lost. From the remainder of the pack, 2 cards are drawn and are found to be spade. Find the chance that the missing card is spade. Okay, so we have 52 pack of cards and 1 is lost. So we'll have 51, and from 51 cards, 2 cards are drawn and they are found to be spade. So we need to find the chance that missing card is paid. So I'll consider these events. E1 is missing card is paid. E2 is missing card is not paid. So if you see, E2 is non-event of E1, correct? Because they are complement of each other and together they form the entire sample space. Okay, so and then A, I'll take 2 cards drawn are spade. Okay, and what we need to find the chance that missing card is spade, and it is given that the 2 cards are drawn were spade. So this one we know it is E1 intersection A divided by P of A. So P of A we can easily find. So what is P of A? 2 cards drawn are spade. Again, so what I'll do from 52, right? So spade cards is 13 only. So 13C2 will be, all 2 cards will give me spade, divided by total combination is 52C2. So this will be 13 into 12 by 52 into 51. So this goes 4 times. So this goes 3 times. So 3 by 51, P of A, right? And how do we find P of E1 intersection A? So missing card is paid, and then I'm drawing 2 cards and I want to find the intersection between these two. So it is not direct to find it. So what we do is, I know P of A given, I can find this one easily, correct? If I know the missing card is this, then I can say what is the probability that the 2 cards drawn are spade. Okay, so I can calculate this, but this is nothing but P of A intersection E1 divided by P of E1. P of E1 also I can calculate. What is the chance that missing card is paid? So what is P of E1? So there are 13 spades divided by 52, correct? So the missing card being spade will be 1 by 4. And P of A given E1. The missing card is paid, okay, we know that. Then what is the probability that both the cards drawn are spade? So now spades will be reduced to 12 from 13, right? So 12C2 by total cards itself will be reduced to 51C2. So this is 12 into 11 by 51 into 50. So let's keep this like that only. And then what we have, we need to find this. If you see, P of A intersection E1 is nothing but P of E1 intersection A, correct? So we can find this by cross multiplying here. So P of E1 intersection A is nothing but P of A given E1, which is 12 into 11 by 51 into 50 into P of E1, 1 by 4. So this, if you see, it goes 3 times. So it is 3 into 11 by 51 into 50. Now I can easily find P of E1 given A. That is what they are asking. Find the chance that missing card is paid, where it is already given that the 2 drawn cards are spade. So P of E1 given A is nothing but this value, 3 into 11 by 51 into 50 divided by P of A. P of A is 3 by 51. So if you see, these cancels. So what will I get? 11 by 50. So this is how you do this question. So since I have written out all the formulas, it may seem like time consuming, but if you just keep the formulas in mind and try to just calculate it, you will be able to do it quickly. So this is 11 by 50. Okay guys, that's it for today. Have a nice day.